myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about instruction format. At the end of this video, the student can gain knowledge regarding what are various instruction formats, how to use these instruction format for evaluating the expressions, and they can differentiate in between various categories of instruction format by considering various examples. The basic agenda of this video is the introduction, what is instruction format, what are the types of CPU organization, what are the types of instruction formats, and finally we will look into the examples regarding various categories of instruction formats. The computer can perform any task based on the program or instruction supplied by the user. So, the instruction or the programs are the major input to derive an information or a functionality from the computer. So, a program is a set of instructions that specify the operations, operands, and the sequence by which the processing has to occur. The program is collection of instructions, and these instructions can be executed one after another in a sequence, and the instruction can originate the operations that can be performed on the operands. Based on these instructions, the program can be executed generally in a sequence. So here the instruction can consist of the operations and operands. So an instruction code is a group of bits that instruct the computer to perform specific operation. What is instruction format? The instruction is divided generally into two parts. One is the opcode or operation code, and the second part is address. The opcode specifies which type of operation can be performed, like the addition operation, multiplication operation, complement, compare. So, which type of operation can be performed is specified with the help of opcode or operation code. But this operation and which data this operation can be performed, that is specified with the help of address. What is the address that is specified in the instruction format? There, the operand can be identified. So here the instruction format consists of two parts, opcode and the address. The operational code of an instruction is group of bits that define operations. So for example, the add, subtract, etc. The opcode must consist of at least n bits for a given 2 power n operations. The operation can be performed on some data stored on the processor register or in memory. So here the operands can be fetched based from the memory or from processor registers. An instruction code specifies not only the operation but also the registers or the memory words where these operands are to be found, as well as the registers or memory words where the results are to be stored. After performing the operation, whatever results that are generated can be stored. Where these results can be stored is also specified with the help of instruction code. So, the operand part, the address part can specify where the operands are located and where the results are to be stored. Memory words can be specified in instruction code by their address. So two parts, one is the opcode, the second part is the address. So this is the format of the instruction. So majorly two parts. One is the opcode, which can specify the operation. The basic operations can be either arithmetic operation like addition, subtraction, multiplication, division, or logical operation like AND, OR, XOR. Otherwise shift operations, shift left, shift right, like this. The operation can be specified with the help of opcode. Next, on which data this has to be performed, where the operand is located has to be specified by the address. And here the mode of the address can be specified with the help of last bit or the MSB of the instruction format. Here two modes are possible. One is direct addressing mode, second one is indirect addressing mode. The indirect addressing or direct addressing has to be decided with the help of MSB bit of the instruction format. If the MSB bit, the 15th bit of the instruction format, can be denoted with the I value. If I value is 0, then it is a direct addressing mode. If I value is equal to 1, then it is a indirect addressing mode. In the direct addressing mode, what is the address specified in the instruction format? There itself the operand can be available. But in case of indirect addressing mode, the address specified in the instruction format, there the effective address of the operand can be found. So the addressing mode can be specified in the last MSB bit of the instruction format. So here, based on the opcode, the types of the instructions can be easily identified. So the basic computer instruction formats are depending upon the opcode and the I value, the which type of instruction can be easily identified. If the opcode value is 000 through 110, then these instructions come under the category of memory reference instruction. So the operand can be available in the memory locations. Next, if the opcode is 111 and I value is 0. So here I value has to be 0, means it is a direct addressing. If the opcode value is 111, then these instructions come under the category of register reference instructions. So the operands can be available in the CPU registers. Next, the third category of instructions are IO or input output instructions. If the opcode is 111 and I value is equal to 1, then these instructions come under the category of input output instructions. So these are the basic computer instruction format. Next, we have to look into what are the types of CPU organizations. So here majorly three categories of CPU organizations are available. One is general register organization. The second one is single accumulator organization. Third one is stack organization. General register organization means by using the CPU registers, the operations can be performed with the help of these CPU registers. Next, in case of the stack accumulator organization, the operands can be stored in the stack and can be popped before applying the actual operation. And in the single accumulator organization, one component has to be used as the accumulator, and the other one is the other operand can be identified with the help of the address specified in the instruction format. So here in the general register organization, the major component that can be used to store the operands are the CPU register. In case of single accumulator organization, one operand can be stored by using the accumulator. In the stack organizations, stack data structure can be used to store the operands. These are the three types of CPU organizations. What is a register based CPU organization? So in the CPU, here the ALU can has to be performed the arithmetic and logical operations. So based on the register and general purpose registers, those can has to be used in the CPU organization. For example, if you want to perform add instruction, add, then the registers, the CPU registers can be used to take the operand value as well as to store the result also. So here add R1, R2, R3. So R2 in the register, the value stored in the register R2 and R3 can be added, and the result can be, some value can be stored in the register R1. So in CPU organization, instruction format need 2 to 3 register address fields according to the operations. Next is single accumulator CPU organization. So here to perform the arithmetic and logical operation to support the ALU, accumulator is used to store the one operand. The other operand can be fetched with the data register that is specified in the ALU to accomplish the operation that is specified. So here in the CPU organization, all operations are performed on the implied accumulator. The instruction format uses only one address field. The other one is by default the accumulator. So here, if you want to perform any operation here, first operand can be loaded and stored in the accumulator, and that operand can be used in order to perform any operation. For example, if you want to perform add operation, add R1. The register, the value stored in the R1 can be summed with the, which means that accumulator is equal to accumulator value plus the register R1 value. So what is the value stored in the register R1 can be summed with the accumulator value, and the result can be again stored in the accumulator. So accumulator can be used as one address field to store the one operand. Next is stack based CPU organization. So here the stack data structure can be used, and to insert data in the stack, the push operation can be performed, and to fetch the data from the stack, the pop operation can be used. So here these operands can be temporarily fetched in the latches in order to perform the arithmetic and logical unit. The assistance to supply the needed operand for the arithmetic and logical operations, the operands can be first fetched from stack and can be stored in the temporary latches. So here the stack data structure can be used here, and the data can be stored in the stack and can be fetched from the stack with the help of push and pop operations respectively, and these can be done with the help of stack pointer. So this is the stack based CPU organization. So the data can be stored in the by using push operation, and they can be fetched using the pop operation. simply we have to give what operation can be performed. Uh, and these type of instructions generally we can refer it as zero address instruction. Why? Because here the address we are not specifying. The data can be fetched from the stack itself. Only the operation what need to be performed on the data can be specified in case of stack based CPU organization. So these are the three CPU organizations. Based on these organizations, the types of instruction formats can be identified. So these are four categories of instruction formats. One is three address instructions. Second one is two address instructions. Third one address instructions. Fourth one, zero address instructions. What is three address instruction? In this type of instruction, all operand addresses are explicitly defined. And here the instruction formats has three different address fields specifying memory or processor register operands. So the operands are generally available in the CPU registers or from memory. So here opcode can be used to specify what operation to be performed, and here the three addresses can be mentioned here. These can be a register or memory locations. So here these two are generally used for source registers, and operand 1 and operand 2 can be stored in these address 2 and address 3, and the result, the destination register, can be specified here as address 1. So the example we can consider here is add R3, R1, R2. So here this add operation can be implemented on the CPU registers R1, R2 and R3. The value stored in the R1 and R2 can be added, and the result is stored in the R3. So this is a three address instruction. Here the operand addresses are explicitly defined. What are the advantages and disadvantages of these three address instruction format? It results short programs when evaluating arithmetic expressions. Why? Because there is a facility to specify source operands as well as the destination also. And less execution time. It is a single instruction where all the data and opcode is available. So the execution time can be less. What is the disadvantages of these three address instruction format is too many bits are required for binary coded instruction to specify three addresses. So in the instruction, three addresses have to be specified which require many bits. More complex decoding and processing circuits are needed. So here in this instruction, by specifying three addresses, complex decoding and processor circuits are needed. So these are the disadvantages of three address instructions. Next category is two address instructions. In this type, instruction format has two different address fields. Each specifying either a memory or a processor register operand. So here opcode, next two addresses can be specified, address 1 and address 2. So here these two are first act as the source, and the after opcode what is the address is specified, there itself the address 1 can itself act as the destination. So here the example of two address instruction is add R1, R2. The value stored in the register R1 and the register R2 can be added, and the result is stored, the destination part, the result is stored again in R1. So this is the two address instruction format. Now we have to look into what are the advantages and disadvantages of two address instruction formats. The advantage is less execution time compared to one address instructions. So the fetching of operands can be minimized here. Two operands are available, so less execution time can be needed for the execution of two address instructions. Number of instructions needed to evaluate a arithmetic expression is much less compared to one address instruction and the zero address instructions. And the major disadvantages are in result, in comparatively longer programs, three address instructions when evaluating arithmetic expressions. So in the three address instruction, there is a facility to specify the destination address separately. It is a convenient form in the user perception. So comparatively more execution time than the three address instruction. In the three address instruction, destination address, source addresses are readily available. So that's why it is easily, quickly executing the instruction. But comparatively, here two address instruction required more execution time than the three address instruction. Next category of instructions are one address instruction. In this type, instruction format has single explicit address. That's why one address instruction and uses an implied accumulator AC register for all data manipulation. By default, accumulator can involve in all data manipulation operations. One explicit address can be specified in case of one address instructions. So here opcode, next the explicit address can be specified. For example, here add R1. So the value stored in the register R1 is added to the accumulator and the result is stored in the accumulator. So here for the all data manipulation operation, accumulator plays the major role. So accumulator CPU organization instructions generally come under the category of one address instructions. The two and three address instruction formats are generally come under the category of register-based CPU organization. Now the advantages and disadvantages of this type of instruction format. Less complicated decoding is required. Only one address is specifying explicitly. The disadvantage is number of instruction need to evaluate an arithmetic expression is more compared to two and three address instructions. Each operand can be fetched separately. There is a facility of specifying only one explicit address. So the number of instructions, the length of the code can be increased if you use the one address instruction format. More execution time is needed and a limited range of functions each instruction can perform. So these are the disadvantages of one instruction format. The next category is zero address instructions. Such instructions do not contain any explicit addresses. In the three address instructions, the user can specify three explicit addresses. In the two address instruction format, there is a facility to specify two explicit addresses. In the one address format, there is a facility to specify one explicit address. But in case of zero address instruction, no, there is do not contain any explicit addresses. So here the stack data structure can be used. So the operands can be inserted in the stack with the help of push operation and they can be fetched from the stack with the help of pop operation. So with the help of this stack, the operands can be easily pushed and popped and only whatever operation need to perform can be specified with the opcode. So this is the instruction format of zero address instruction. Example, add. the operands are available with the stack. The top on the top of the stack that is pointed by the stack pointer, the operands can be popped and those operands can be added with the help of add opcode. So these are the stack address instructions and can be used in the stack based CPU organization. So these are the 4 varieties of the instruction format. Now we have to look into what are the advantages and disadvantages of zero address instruction. Do not contain any explicit addresses. So instructions are simple. What operation the user need to perform has to write the opcode. The disadvantage is to evaluate arithmetic expressions in a stack computer. It is necessary to convert the expression into reverse Polish notation. So, postfix expression evaluation can be done with the help of the stack. So, conversion is needed for the expression evaluation. This is the disadvantage of the zero address instruction format. Now, with the help of these instruction formats, we can evaluate one expression, that is x is equal to a plus b multiplied by c plus d. So, how this expression evaluation can be carried out with various categories of instruction format we will discuss. So, in the zero address instructions, a stack based computer is used. So, no explicit address can be specified here. So, here we can push the first operands into the stack. The A, B can be pushed. So, they are placed on the stack. And next, add. So, A and B can be added. So, here the A plus B operation is completed. Next, another 2 operands involved are push C, D. So, C and D are placed in the stack. Next, add means here C plus D operation is carried out. Next, MUL means multiply the C plus D into A plus B. So, next, pop X means the top, the result is there, that has to be stored in the X. So, here the expression what is given can be easily converted, first converting to the postfix notation, then the expression has to be evaluated based on this postfix expression. So, here first the expression is converted. So, first the operands can be written, later on the operator can be written. So, here this is the postfix conversion of the expression evaluation. So, that what is the operands involved, those can be pushed first. Next, specify the opcode of the operation. Next, what is the operands involved in the operation can be pushed into the stack. Next, specify the what operation to be performed on it. So, in this way, by using the zero address instruction, the expression can be evaluated. So, the disadvantage of this is the expression has to be converted into reverse Polish notation or postfix expression. Next, the same expression can be evaluated with one address instruction. So, here there is a facility to specify only a single address explicitly, and accumulator can be used for data manipulation operations. So, here A is first loaded into the accumulator, add B. So, the B value can be added already. The accumulator is containing the value of A. So, A plus B operation can be carried out and completed here. Next, store T, the sum that is generated with the help of A plus B can be stored in the temporary variable T. Next, load C, add D. So, here C plus D operation can be performed. D is explicitly specified the address, and C value is already available in the accumulator. Next, multiply T. So already the C plus D value is stored in the accumulator, and here A plus B value is temporarily moving to the temporary variable T. So these values multiplied and the result can be moved to the X. So in this way, one address instruction can be used for expression evaluation. Next is two address instructions. So here the user can have the facility to specify the two explicit addresses. So same the expressions how it can be evaluated with the help of two address instructions. So here first move the register R1 with the A value. Next add the B value with the R1. So here A plus B operation is completed. Next, C value is moved to the register R2, add D to R2. So, C plus D addition is completed here. Next, multiply MUL R1, R2 and move whatever the result multiplication result stored in the R1 to the X. So, in this way, the two address instructions can be used in the expression evaluation. Next is three address instructions. In the three address instructions, there is a facility to specify three explicit addresses. So, how this same expression can be evaluated with the three address instructions. So, here first A, B, add A, B and the result can be stored in the register R1 and add R2, C, D. C plus D can be performed and the result is stored in the R2. Next, MUL multiply X, R1, R2. R1 value, R2 value can be multiplied and the result is stored in the X. Now you can notice that the length of the lines of code can be greatly reduced with the help of three address instruction. That we have to discuss the comparison between various instruction format by taking an example. So here we have taken another expression x is equal to a plus b slash that is divide d minus e into b. How this expression can be evaluated in the 0 address, 1 address, 2 address and 3 address instruction format, and we can compare the various instruction formats. So here in the stack based organization, first we have to convert into the postfix and the operands can be moved to the stack. Next we have to apply the operations. So here the memory location, the operands can be pushed and popped. Then we can give the add, sub, multiplication, division operations in the one address. In case of one address accumulator mission, the accumulator can be loaded and stored with the operands, and then we can apply the operations add, sub, multiplication and division. In case of two address instruction, the operands can be moved to the registers and we can perform the addition, subtraction, multiplication, division operations. In case of three address instructions, the operands can be moved and the register values directly contain the operands. Directly we can apply the arithmetic operations so that the destination address can also be explicitly specified in case of three address instructions. So here when the 0 address instructions are considered, they are purely the stack based one. Push and pop operations are needed, and here the for expression evaluation, the expression can be represented in reverse poly notation so that they can be evaluated easily. and the length of the code can be high in case of the stack machines or zero address instruction format. And coming to the one address instruction formats, so they can use the accumulator for the data manipulation, and there is a need to load and store the values, operand values in the accumulator for processing. And in case of register based organization, there is the two address and three address instruction formats are there. In the two address instructions, this can be specified. There is no facility of mentioning the destination address in two address, but this facility is available in three address instruction format. So three address instruction format, the length of the code can be greatly reduced when compared to the other. And here the execution time can also be optimized in case of three address instruction format. Why? Because the operands are readily available in the instruction format itself. So the execution time, there is no fetching of operand from memory location is needed. So they can be at one step, they can be fetched, and the execution time can be increased in case of three address instructions. But the disadvantage of three address instruction is complicated circuitry can be needed for mentioning the CPU resistance. So this is the comparison between one address, zero address, one address, two address, and three address instruction format. So in this video, I have discussed about the what is instruction format, how opcode and addresses can has to be categorized, what are various basic formats of CPU organizations, the three different formats, register based, stack based, accumulator based organization. Based on that, what are the four categories of instruction formats? Zero address, one address, two address, three address instruction formats are discussed with their advantages and disadvantages, and a comparison is made by taking one expression evaluation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.